Hi everyone, I hope you're well. Today I'm going to go over these two challenge problems over here. You won't be tested on anything like these problems we're going over, but I thought it'd be good to go over some challenging ones for those of you that want to kind of dig deeper into some of these different problems. Look at ones that are maybe a little more complicated than the basic ones that we've looked at, okay? So let's look at this one. A 60-foot ramp makes an angle of 4.8 degrees with the ground. To meet new accessibility guidelines, the ramp must make an angle of 2.9 degrees with the ground. So let's start by drawing this out. So let's draw our first ramp to start. So our first ramp is like this. It makes a 4.8, right? So here's our ramp, makes a 4.8 degree angle with the ground. And it's going up to some platform, right? So this is going to be 90 right here. Okay, and it says that the ramp is 60 feet long, so we can label this 60 feet. Okay, so there's our current ramp. To meet new accessibility guidelines, the ramp must make an angle of 2.9 degrees with the ground. So now we need to adjust this ramp. Well, it's still going to the same place, right? So it's now coming like this and still going right along the same ground. So a ramp looks something like this. How long will the new ramp be? So we want to find this length. Now, we don't have a lot labeled here. We're going to have to fill some different things in. Well, the ramp must make an angle that's 2.9, so we can label this angle 2.9 degrees. Right here, we can calculate this angle pretty easily. If we know that the other angle is 4.8, this is a linear pair. So this angle right here is going to have to be 175.2 degrees, okay? And then if we know two angles in a triangle, we can find this one pretty easily by adding those up and subtracting those from 180, and we're left with 1.9, right? So now we have some different things filled in our triangle. How long will the new ramp be? Well, looking at this red triangle here, I have an angle and a side opposite. That's the side 50. An angle, I want to find the side opposite. So I'm going to set up, right, an equation to solve for the length of the new ramp. So I would say sine of 2.9 over 60. So that's a side angle and the side opposite equals sine 175.2 over the side opposite x. Okay, I'm going to cross multiply here. So I get x sine 2.9 equals 60 sine 175.2. I want just x by itself, so I know I have to divide by sine 2.9. Right, and I get x equals 60 sine 175.2 all over sine 2.9. Great, right? Now that I have all that, I can plug this whole thing in my calculator, plug it in all at once, and I get 99.24 feet. So the new ramp would be 99.24 feet, okay? All right, so now how much further along the ground will this new ramp extend? So for this next problem, we are looking for this distance, right? We're figuring out how much further extends along the ground. So we want to figure out that. So I can set up another equation. We have some information. I have an angle and a side opposite still. An angle, I need to find another side opposite. I'm going to use law of sine. So sine 2.9 all over 60 equals sine 1.9 over y. Okay, cross multiply like I did with the last problem. Y sine 2.9 equals 60 sine 1.9. Divide by sine 2.9. So I have y equals 60 sine 1.9 degrees over sine 2.9. Once you have your equation set up, you can plug all that in your calculator and you get that y equals 39.9 0.32 feet. That's the how much further along the ground that would extend. Great. All right, let's try one more. In a ship sailing north, a woman notices that a hotel on a shore has a bearing of north 20 degrees east. A little while later, after having sailed 40 kilometers, she observes that the bearing of the hotel is now south 80 degrees east. How far is the ship from the hotel at the time of the second sighting? Okay, so first we're going to draw a picture here, and I'm going to draw out my compass. So here's our compass, like this. Never eat shredded wheat, or never eat soggy waffles, right? There's our compass. So we have to use that as we do this. I'm going to copy it down again down here. Okay, so the ship right here, right? So in a ship sailing north, so here's the path of the ship that we see right here, right? This is the path of the ship. A woman notices that a hotel on the shore has a bearing of north 20 degrees east. So since this way to the right of this line is east, this angle right here, 20 degrees, is north 20 degrees east. So from north, it's 20 degrees east, right? That's what that means. From north, it's 20 degrees east. So 20 degrees east, she notices a hotel. So right here, we have the hotel, okay? A little while later, after having sailed 40 kilometers, and remember, they're headed north, so this is 40 kilometers, she observes that the bearing of the hotel is now south 80 degrees east. So from up here, from south, 80 degrees east. So this is 80 degrees. How far is the ship from the hotel at the time of the second sighting? So what we're trying to figure out is this length right here, right? Well, if we know these two angles, we can calculate this angle really easily. 180 minus 80 minus 20 leaves us with 80 degrees for this angle, right? And now we need to solve for x. Well, I have an angle and a side opposite, angle and side opposite, so I'm going to use law of sines. Sine of 80 over 40 equals sine 20 over x. Okay, I'll cross multiply. X sine 80 equals 40 sine 20, and divide by sine 80. And I get 40 sine 20 all over sine 80. Okay, I would plug that whole thing in my calculator, and I get that x equals about 13.89 kilometers. So the ship is about 13.89 kilometers from the hotel. Great. Again, email me with questions. Hope you guys are well. Talk to you soon.